And as soon as it comes on the screen, we'll be good. There, it's warming up. If you're following along in your textbook, it starts on page 9. Page 9 in the textbook. Conditionals and biconditionals. So we have some definitions. For propositions P and Q, the conditional sentence P implies Q is read if P, then Q. The proposition P is called the antecedent and Q is the consequent. The conditional sentence P implies Q is true if and only if P is false or Q is true. So this is a truth table for P implies Q. Notice if P is true and Q is true, then if P, then Q is going to be true. And if you think about this, suppose P is going to be you get an A, and Q is going to be I pay you $100. Okay, so if you get an A and I pay you $100, I've kept my promise, right? Think of this as a promise. Now, if you get an A, but I don't pay you $100, have I kept my promise? No. This is a case where the promise was broken. How about if you didn't get an A? If you don't get an A and I pay you $100, have I broken my promise? No. The promise contract was never entered into because you didn't get the A. Okay? So promise is not broken. And how about the last one? You didn't get an A, I didn't give you $100. Did I break my promise? No. The promise is still not broken here. The only one where the promise is broken is that second one. If your part of the agreement is upheld and the conclusion doesn't follow, then it's a false statement. That is the hardest thing for people to think of. If P is correct and Q is not correct, then if P implies Q is a false statement. So when is this true? This is true whenever you have a true, true is true, false, false, or true. So it's always true if the first statement is false. And the only other time is when both P and Q are true. Notice if the second statement is false, you can't make any conclusions. Because in one case, true, false ends up being false, and false, false ends up being true. So you can only make your conclusions when your first statement is false. First statement false is going to give you a true for an answer. Notice if the first statement is true, you also can't make any conclusions because you have a true false case. Okay, keeping that in mind, let's identify the antecedent and consequent of each sentence and then determine the truth value of each. So what is the antecedent for this first one up here? Yeah. Well, actually, it's everything except the if. The concert is sold out is the antecedent. How do you spell that? Antecedent. And what is a consequent? I will take you sailing. Is this a true or false statement? Or can you figure out whether it's true or false? Yeah, it is a proposition, but we can't figure out the truth or falsehood of it because we don't know whether I will take you sailing is going to be a true statement or not, or the concert is sold out. We can't determine those, but it's still a proposition because it's in the form if P then Q. So undetermined, true or false. I can't determine the truth or falseness of P and Q, so I can't determine whether that's true or false. Tell me about Isaac. If Isaac Newton was born in 1642, then 3 times 5 equals 15. What's the antecedent? 1642. So that's the antecedent. And the consequent? Now, tell me about this consequent. Is that true or false? That's true. If the consequent is true, then the whole statement is going to be true because it means I have kept my part. So this is a true statement. Even though we don't know when Isaac Newton was born. I don't know when he was born. Someone knows when he was born, but it's definitely not me. So this is a true statement. What is the antecedent in number 3? Yeah. And what's the consequent? X is greater than 5. Now, what's the rest of this? This is just a definition. That's something in the periphery, but it's not part of the if P then Q part. So, tell me about this. True or false? Yeah.
We don't know.
It's true. Yeah, if X is bigger than 8, then X is bigger than 5 is going to be a true statement. And if you're unsure, you can plug in different values for X. So what happens if X is 9? Yeah, so that would be the true case. So the answer is going to be true. If X, make it smaller than 8, make it 7. X is greater than 8 is false. X is bigger than 5 is true, but false implies true is going to be a true answer. Okay? X is 4. So you're going to have false, false, but that is still a true answer. The only one that is false happens when true false case.
Why is it false equals true?
Because remember, this is if P then Q. It's a contract.
Oh.
If the first one fails, it doesn't matter what happens after that. You're going to get a true answer. So that one is actually true. Okay, let's go on to the next definition. Let P and Q be propositions. The converse of P implies Q is Q implies P. The inverse is not P implies not Q. You negate both. And the contrapositive is not Q implies not P. Negate and switch. So converse is switch the order. The inverse is negate both of them, but keep the order the same. The contrapositive is negate and switch the order. So keep that in mind. We're going to actually, so I'm going to write it this way. For P implies Q, the inverse is going to be not P implies not Q. The converse is going to be Q implies P, and the contrapositive is going to be not Q implies not P. we're going to write some phrases down using this definition. Okay, so let's go look at that. State the converse, inverse, and contrapositive of each. So I'll do one right here. Pi as an integer is going to be P. 14 as even is going to be Q. So P implies Q. If we want the converse of that, Q implies P. So that's going to be in English. They're going to want it written in English. If 14 is even, the converse. Yeah. I probably should have written that down first, but if 14 is even, then pi is an integer. Well, that's an E. The E became a G. And so this is a converse. Now then, the inverse is going to be not P implies not Q. So what would that be in English? If pi is not an integer, then 14 is not even. And what's the contrapositive? Yeah, not Q implies not P. So now, let's go and look at the truth, or it says which of the four sentences are true. So let's look at each of them. Is 14 even? That's true. Is pi an integer? Yeah, so true implies false is equal to false. So that one is false. Look at the next one. If pi is not an integer, true or false? True. 14 is not even, true or false? So true implies false is false. So that one's false. And then the last one. 14 is not even, true or false? False. Pi is not an integer, true. So false implies true is true. So which one is true? The contrapositive is true. And let's look at the original. Pi as an integer is false. 14 is even. So false implies true is true. So notice that the original and the contrapositive have the same truth value. They're both true. The converse and the inverse are both false. Okay? We're going to find that. That's actually going to be a theorem of ours. The contrapositive is going to have the same truth values as the original. So tell me about the converse for number 2. P is 1 plus 1 is equal to 2, and Q is square root of 10 is greater than 3. So the converse is Q implies P. Oh. I ran into my other sentence, so we'll draw a line. The inverse is going to be not P implies not Q. So if 1 plus 1 is not equal to 2, then what? Yeah, it's not greater than 3. That not greater than is the same thing as less than or equal to. Okay, so less than or equal to 3. And then contrapositive. Not Q implies not P. So not Q, not the second. It's not equal to 2. Yep, that's exactly correct. Now, let's look at the truth value of the first one. 1 plus 1, is that equal to 2? So that one is true. Is the square root of 10 bigger than 3? Yes. So true implies true. That's going to be true there. Come down here. Square root of 10 is bigger than 3. 1 plus 1 equals 2. So true implies true. We get true there. Tell me about the second one. 1 plus 1 not equal to 2. False. Square root of 10 less than or equal to 3. So false implies false is true. And then the last one. Square root of 10 less than or equal to 3. False. 1 plus 1 not equal to 2. So in this case, everything was true. That can happen. But if it's not true for all of them, then the original statement and the contrapositive will have the same truth value. Okay. So
What if you had a
what if you had a
false? And
so you had your sentence was false implies true to begin
would
with.
it be true?
False implies true is going to be true.
And then you have true.
If you have true implies false, that's going to be false. Yeah. In fact, that's the only time when you get false for the implication. Okay, so we have a theorem here. It says for the propositions P and Q, P implies Q is equivalent to its contrapositive, not P implies not Q. That's what we saw in what we were doing before. And P implies Q is not necessarily equivalent to its converse, Q implies P. In other words, there are cases when they're not going to be the same. How do we look at that? Suppose we're trying to prove this. We have to make a truth table, right? So let's make the truth table. What goes under the P column? True, true, false, false. What goes under Q? Okay, now let's look at P implies Q. Q is just not doing well today. There we go. So that was true, false, true, true. And then let's look at not Q. So that would be false, true, true. And let's look at not P. False, false, true, true. And then not Q implies not P. So be careful of the order. We're going from here to P. False implies false. True. True implies false. False. False implies true. True implies true. Are those two, I'm going to call this 1 and 2. Are column 1 and 2 the same? Do they have the same order? True, false, true, true. True, false, true, true, right? What's your question?
How do you know the pattern for supposed to just continue? Because you have 15 species at that.
It's
How did you know that was having?
okay. First of all, you know that you have 2 to the number of variables. I have 2 variables, P and Q. So I know I need 4 values. Half of them have to be true, and half of them are false. And for the first one, it's always the first half are true and the last half are false. And then you split it in half for the next one. So now, instead of 2 true and 2 false, it'd be 1 true, 1 false. I wasn't really paying attention to that. Yeah, it does do it opposite. Do it this way. I got all my answers written this way. Yeah, you don't have to make the changes on this homework assignment, but this is the way that I've always taught it. I just didn't pay attention to what they had at the beginning. I just said, oh, it's a truth table. I can do that and went on. Yeah, I didn't read the book very well. What's really sad is I've been teaching out of this book now probably, let's see, 5 years, I think. 4 years, thereabouts. And you're the first one who's actually caught that. So congratulations, you read the book. I'm so pleased. I am pleased. It makes me happy. Okay, so let's carry on. So the columns 1 and 2 are the same. What's the conclusion? Well, how about equivalent? So P implies Q is equivalent to not Q implies not P. So those are equivalent statements. Now, how do I show part B? We have to look at Q implies P, right? Well, I can just tack it on the end of this one because I have P implies Q. I can just do Q implies P. Or you can make a new truth table, but I'm getting lazy.
Do you want us to do all of these truth tables, or do you want us to do the because some of them, considering what all of them, there only be like enough for maybe the last group. Like, like the ends already set up for us.
Oh, that's because I didn't actually set up enough columns for you to be able to do them all. I expected you to go in and put in the rest of the columns. I am wanting to see all that work. Yeah. On the test, I want to see all that work. If you're typing it up, you can type in the answer column on it. Yeah, we'll save you typing trouble. But make sure that you can give me all the work on the test. Yeah. So if you're doing Q implies P, that means you're starting from here and going towards P. So true implies true is what? True. Now false implies true. True. True implies false. False. And then false implies false. Now is this going to be, this is column 3. So tell me about column 3. Is that the same as column 1? So those are different, right? Because true, true, false, true is not the same as true, false, true, true. So P implies Q is not equivalent to Q implies P. And that is our proof. Any questions on that? So far, we like proofs, right? It doesn't. Truth tables are easy. Okay, construct the truth table for the sentence P implies Q and Q implies P. So this is going to be true, true, false, false, then true, false, true, false. P implies Q. What's that going to be? True implies true. True implies false. False implies true. And true, true. And then Q implies P. True, true, false, and true. And then we have to put both of those together with an and. Okay, true, false, false, true. Under what conditions from P and Q do you get true over here? The answer is true when you have true, true, or false, false. So this is true when P and Q have the same truth value. It could be both false or both true. So tell me about when they have false for an answer. Yeah, they're different. Okay. This is going to be important for us because it turns out P implies Q and Q implies P is going to be the same as what we call the biconditional P if and only if Q. This is called a biconditional. So the biconditional is true when the truth values of P and Q are the same. It's false when the truth values are different. Okay, so that is this definition right here. For propositions P and Q, the biconditional sentence P if and only if Q is a proposition P if and only if Q. P if and only if Q is true exactly when P and Q have the same truth values. And we write PIFF, that means if and only if. PIFFQ to abbreviate it. The truth table for this, if you put your column down here, is the same thing that I got for my answer column in the previous one. And it's the same as the previous work that we did. Okay, so keeping that in mind, let's look at some truth values of these sentences. 2 cubed equals 8, true or false? 49 is a perfect square. So true if and only if true. True or false? True. They're both the same. Pi equals 22 over 7. True or false? Let's have a discussion about pi. Pi is called an irrational number. Yeah, so irrational means can't be a fraction.
Right. But
It is close. In fact, that fraction was used by the Greeks to represent pi. Hence why we have it there. But we know, the Greeks didn't, we now know that this is not actually equal to pi. So this is actually going to be a false statement right here because pi can't be a fraction. And square root of 2 is a rational number, true or false? False. False, if and only if false? True. Here again, square root of 2 is not equal to a fraction. We actually end up proving that in this class, last half of the semester. It's actually a very, very famous proof that goes back to the end of the time of the Greeks. Which one that goes back to? Okay. Construct a biconditional sentence which is false. How do you get one to be false? One has to be true and one has to be false. So let's agree to make P true and Q false. So give me a sentence for P. What are you going to make? 2 plus 2. We want it to be true. If 2 plus 2 equals 4, if and only if. And now we need a false sentence. One has to be true, one has to be false. Notice that you can put it in either order. I could have written it this way. I could have said 3 plus 2 equals to 4 if and only if 2 plus 2 is equal to 4. You can have a whole bunch of questions, and they're going to ask you to write biconditional sentences that are false, or they're going to ask you for a conditional sentence, P implies Q, which is true, whose converse is false, and stuff like that. So you're going to have to think about how to make up these sentences. it's easiest if you go back to determine what do you need. So if I had said a conditional, true conditional, whose converse is false. So help me out. A conditional is P implies Q. Wait for the computer, there we go. And the converse is going to be Q implies P. For the converse to be false, we need Q to be true and we need P to be false. So you would have to give yourself, and over here, this would be, if you had false implies true, this is true for your answer. So you need Q true and P false. So you would say, give me a false statement. If pi is rational, then now I need a true statement. Yeah. And now you've constructed it. So it's easiest if you go back to writing your true and false values down. What do you need each one to be, true or false? And then you can figure out how to construct your sentence. You're going to have a whole bunch of these. You'll have a headache before you're done. Just in case you were wondering. Any questions on that? Okay. Definitions are biconditional statements. Note that the sentence says zebra is a striped animal is not a definition. Why? It's not if and only if, right?
Yeah, zebra. Or animal which is striped.
Yeah, an animal which is striped doesn't have to be a zebra. What is a striped animal which is not a zebra? A tiger, skunk. There's a number of them. So this is not a biconditional. It's not a biconditional. It doesn't go back the other direction. So watch that. They're going to ask you that question on your homework too. What's your question?
Biconditional statement has three numbers here.
And an if and only if in between.
So those are multiple reasons why that sentence is modified.
Yeah. You could reword this sentence to be, if it is a zebra, then it is striped. So you could reword it into a conditional, but it doesn't go the other direction. If it is striped, then it is a zebra. So you can get it to be a P implies Q, but you can't, Q implies P is not also true. They have to both be true for it to work. Yeah. Any other questions on that? Okay. Recall that two propositional forms are equivalent when they have the same truth values. That's going to be important. Since the bicondition is true only when the truth values of the two propositions is the same, either both true or both false, it follows that the propositional forms P and Q are equivalent precisely when this is a tautology. What is a tautology? All true. So all true means that they have exactly the same forms. That's what that is saying there. That is a quote straight out of the book. We have here a theorem. This theorem has multiple parts. So let's go ahead and break it up and see 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There are 7 of you and 7 parts. So pick a part and do it yourself. Write it down. What is your goal for each part on this when you're doing it? You're trying to see that you get the same answer columns for each one of them, right? So let's just do it in order. A, B, C, D, E, F, and G. Okay? A, B, C, D, E, F, and G. And go ahead and do those. Let me actually pause the video recorder while that's happening. I know it's hard.